Okay, this is part 2 of our review for test 8. We're doing standard 11, which is graph the roots, surface learning. So it says, how many real roots are there in this graph? Well, the roots are where they cross. The real roots are where they cross. So there has to be 1, 2. The answer is 2. 2 real roots. Which root has a multiplicity of 2 for this graph? So let's go down here. Look for where it has multiplicity of 2. So when the graph goes straight through the x-axis, okay, all we're looking for on this, let me make sure it's clear, is this is the x-axis, this line right here. And we care where this graph in blue crosses that line. So you should be able to notice it crosses there, there, and hits it there. So here, it goes straight through the graph. It goes straight through that line. That has a multiplicity. That's a root of x equals -4, because that's where it's at, -4. It's kind of hard to see. I can erase this. That's a root at -4. And it has a multiplicity of 1 because it goes straight through. So just a regular root. It also has a root here at -2. So this is another root. X equals -2 with a multiplicity of 1 because, again, it goes straight through. But notice here it bounces off. The graph bounces off. It goes down, bounces off the axis, right at 3. So there we have another root, x equals 3, and there's actually 2 roots there, another x equals 3. Now we usually don't write it twice, we just say multiplicity of 2. Meaning it hits it twice. It bounces off, so you get 2 roots there. So if we were to put this in factored form, this would be x minus 3, because it's the opposite of positive 3, squared, because the multiplicity of 2. And then we'd have an x plus 2, because the opposite of -2. And then we'd have an x plus 4. So if I were to FOIL this out, I'd have to do x minus 3 times x minus 3 times x plus 2. I'd have to do a lot of foiling. But if I were to FOIL this out, this times this, get an answer, put it in parentheses, FOIL it with this thing over here, the x plus 2, FOIL it with that, and then FOIL it with, get an answer and FOIL it again with this thing, x plus 4, FOIL all the FOILs, then I would end up with a polynomial that looks like this if I were to graph it, okay? So that's what's going on. So the question was, which root has a multiplicity of 2? The answer is x equals 3, okay, or 3. What are the roots for the graph? So we just kind of went over this. There's one here, there's one here, there's one here. So as long as these are 1, which I'm assuming they are, so -1, -2, -3, -4. So -4, -1, and at 2, 1, 2. So what are the roots? X equals -4, x equals -1, and x equals 2. Okay, those are the roots. Moving on. 11, deep learning. What are the factors for this graph? So factors off of the graph. So this is what I was going over last time. This is a double root, this is a single root, this is a triple root. So the factor here would be the opposite of -3, so it's going to be x plus 3, but it's a double root, so squared. The factor on this one here is x plus 1, and it's just the first power because it goes straight through. And then we have a triple root here, all right, triple root, because it does the crazy little wiggle. This thing. When it does that wiggle, I didn't do a very good job like that, which is exactly what it does, that wiggle. Then, or it could go the other way like that. Then we have cubed, triple root. So we're going to have x minus 4 cubed. All right, those are the factors. What's the multiplicity of root x equals 4? So here is a root of x equals 4. Multiplicity is doing the wiggle thingy. So again, this would be a triple root. So the multiplicity is 3. Standard 12, composition of functions, surface learning. Evaluate the function f of g of 4. The way this works is you take 4, you put it in for x in the next inside function, which is g. So I'm going to take 4 and put it into g there. So I'm going to put 2 parenthesis 4 squared. So 2 is right here. X becomes 4, and it's squared, so there's the square, plus 3, plus 3. So all I'm doing is copying down what they had, okay? But I'm replacing the x with 4. That's it. Now I got to figure out what that is. So 4 squared is 16. Remember, you got to do PEMDAS, so you got to square first, exponents before multiplication. So 16 times 2 is 32, plus 3 is 35. All right, so the answer is just 35. We're done. Number 17, evaluate h of j of 4. So, okay, j is the inside function. So we're going to plug 4 into j. Hey, that's down here. So it's going to be 4 squared plus 3. Okay, I feel like we just did this. That's 16 plus 3. That's 19. Okay, now I'm going to take 19 and plug it into h, the next one, h. So 19 goes in here. So this would be 19 cubed minus 2. All right, we got to figure out what 19 cubed is because it's not nice. So I'm going to do this on the calculator. I get 6859. So it's 6859, and then I subtract 2. So it'd be 6857. That's it. We type that into the computer. We get it right. All right, 18 is kind of tricky. What is the function that represents f of x equals y? So I have 4, I have 11. So the question you need to ask yourself is, what do I do to go from 4 to 11? So I don't know if you remember the lesson in class where we guessed the function. That's what we're doing here. So how do I go from 4 to 11? Well, there are lots of different ways, right? It could be add 7. So you might think the function is add 7. But it has to work for all of them. So if I add 7 to this, 12 plus 7 is 19. That's not 19. 13 plus 7 is 20. That's not 20. So it doesn't work. So add 7 is not right. All right, we know add 7 is wrong. What else? It could be multiply by something and then add or subtract something. So it might be multiply by 3 and subtract 1. So if I do 4 times 3 minus 1, that would give me 12 minus 1, which is, of course, 11. That works. If I multiply this by 3, so it'd be 12 times 3 minus 1. Try the same rule. That'd be 36 minus 1. That's 35. That's not 35. Okay, so let's go back. So it's not multiply by 3, add or subtract 1. What if it's multiply by 2 and then add something? So it would be 4 times 2 would be 8, and then add 3 to get 11. So if I do times 2 plus 3, let's check and see if that works. So it would be 8, 2 times 4 plus 3. So like I said, it'd be 8 plus 3 is 11. All right, let's do 2 times 2 times 12 plus 3. So that would be 24 plus 3. That is 27. All right, looks like that's what we got. Like this is the correct one. So it would be times 2 would be 26 plus 3. That would be 29. And then this would be 62 plus 3, that is 65. All right, so the answer would be multiply by 2 and then add 3. All right, standard 12, composition of functions, deep learning. This is a more difficult type of problem where we're going to take the inside f of x, the whole equation for it, which is x minus 3, and plug it into x squared. So I warned you in class that you would have a problem like this, that you'd have to plug it in with parentheses, and I'm just going to take x minus 3 and put it in for that x. So that x is going to become x minus 3. Now, where people screw this up is they say that this is x minus 9, or x squared minus 9, or x squared plus 9, or something like that. You have to FOIL this. This needs to be FOILed. So this is x minus 3 times x minus 3, and then we have the minus 3. So when I FOIL this, I'm going to have to write it up above, but I have to multiply these four things together. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x would be negative 3x. And negative 3 times negative 3 is positive 9. And then I need to subtract 3. So I get x squared minus 6x plus 6. That would be my answer. And the last one is going to be the hardest one. We have to do 3 functions. So we got inside of h getting plugged into f, that answer getting plugged into g. So first let's start with h. H is x minus 2. Okay, what's it going into? F. F is this. So I'm going to do x minus 2 squared plus 5. So x minus 2 squared plus 5. FOIL again, x minus 2 times x minus 2, and then add the 5. So x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. And then we add the 5. Okay, so we got to simplify this. So this would be x squared minus 4x, because we're going to combine those like terms, and we're going to combine those like terms. So that would be plus 9. Okay, take all of this and plug it into the next function, which is g. So I'm going to plug this into g. So I get all of that minus 4. So if I subtract 4 from this, it would be x squared minus 4x plus 9 minus 4. Well, the only thing I can do with this is combine our like terms. So this would be x squared minus 4x plus 5. That is my final answer. Sorry for all the highlighting. That's not the answer. So that is the actual answer right there. Standard 13. If the input into f of x is 2 and the output's negative 8, then the input of negative 8 into the inverse must have an output of 2. Remember, the opposite, the things switch. So if 2 goes to negative 8, then negative 8 will go back to 2. Find the inverse of this function. This is what you're doing on your project. So it's already written as y, so we're going to switch x and y. So it'd be 3/4 y minus 6. We're going to add 6 to both sides. So we get x plus 6 equals 3/4 y. And then we're going to multiply both sides by 4/3, the reciprocal. 4/3. Put it in parentheses. Now these make 12 over 12, which cancel. This can be written in 2 ways. The answer might be 4/3 x plus, let's see, go over here, 4/3 times 6 over 1. So 4 times 6 is 24. 3 times 1 is 3. 24 divided by 3 is 8. So the answer would be 8. So this equals your new y, and remember we want to write it as the inverse, so 4/3 x plus 8 would be what we put down. Okay. Number 23, or I guess I can talk about the other way. Go back to 22. We could also multiply, we'll go back to this, I want you to look up here at this. You could think of this being over 1, and the 3 and multiply with that, and the 4 distributes, so it would be 4x plus 24 all over 3. This is the other way that you could have the answer. Okay, you still need the f inverse, you still need this f inverse of x. Whatever. Graphs of inverses are reflections over y equals x line. Okay, y equals x line. Remember on the graph, that's this diagonal line. That's where we placed our mirror. That's always the line of reflection. Let's finish this. 24, the graph of G is the inverse of F, and F is this. What is G? All right, so we just need to find another inverse. So we do y equals 3/4 x minus 8. We switch x and y. And now we solve for y. So we add 8, x plus 8. And we multiply by 4/3, the reciprocal. We don't forget to put parentheses around that. That way we multiply the whole side by 4/3. We distribute, so 4/3 x plus 32 over 3. You could do it like this, or we could just multiply the 4 through, so it'd be 4x plus 32 all over 3. Okay, either one, it's multiple choice, so you got to figure out which one I use. Draw the inverse of this graph. Okay. So the easiest way, remember, this should be a reflection over the line y equals x. So dot, 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 dot. That's the mirror. So one of the things I like to do is find a point and then flip its coordinates. So this point would be -2, 0. So I'm going to do 0, -2. That's right here. This point's also pretty obvious. It's 0, 4. So the flip would be 4, 0. That would be a little off the graph, but over here somewhere. Also, they look like they cross right here. So we could draw this straight line. Boom. And that would be the answer to that one. All right, that's the entire test. I hope you guys got something out of that video and can do well on it tomorrow. Thanks.